Hi, in this video we'll be having a look at ExPresS-XR's data gathering system. The system is designed to allow basically any value to be extracted from your XR app. To add a data gatherer, you can right-click in your scene hierarchy, go to ExPresS-XR and then select Data Gatherer at the bottom, or simply add a component to any game object you like. We will start with the basic properties of this component. Starting with the export, we can either store data locally or send it via HTTP to a remote server. This will help get the data from remote applications. For a local data, you must provide a local export path, which is a subpath to the file you want to store it. In this case, DataGatherer values.csv. The data gatherer makes sure that it stores the values to a location where it can write files. So when you are using the data gatherer in the editor, this will be under assets and then in this case data, and you can see the file was already created. When you finally build your application and run it on the headset of your choice, this path may change relative to your app and your VR headset. Switching to HTTP, you can enter a HTTP address where the data should be stored. Be aware that you have to set up an HTTP server to accept your requests. And obviously, we can do both, where we can send data to a server and store the data locally too. Next, we'll talk about export triggers, for which we have 3 different options. 2 of those options can be configured within the editor of the component itself, and we'll get to the 3rd option later with an example for using the button quiz. The first option is to export values when an input action is triggered. For example, we can add another input action reference for the left trigger of a VR controller. In this case, this will be XRI left hand interaction select. And now when we hit the select button on our XR controller, we will trigger an export. Additionally, we can enable periodic export, which will export values depending on the frequency given on the periodic export time. In this case, every second, or for example, we can enter 20 seconds, which will export values every 20 seconds. In this case, as we have the interaction still added, also when we press the left select button. Next, we'll come to the values that can be exported. The first option is to include a timestamp, which will be a Unix timestamp that'll match the moment where the data was gathered. Now we come to the DataBindings, which allows to select data from basically any component within your app in a similar way as the Unity event system works. For that, we will add another entry in our list, and we can add an export column name, which represents the column name within your CSV table. Next, we can select an arbitrary game object, for example, our directional light, and drag it into target object slot, which allows us to first select the component where we want to extract things from, and then the actual value. For example, we can export the name of type string from the directional light, like that. This method will allow the export of most types within your application, such as integers, floats, strings, vectors, and rotation values. As the data bindings require some sort of game object within your scene hierarchy, some values cannot be exported in this way. Input actions can be added to the list below to the input action data bindings and will be exported automatically. In case of static fields or functions or more complex data types, you will need to create a simple script to attach it as a component to a game object within your scene. To do so, create a new empty game object and add a component which will be a new script which we will create right now. Opening the script in your preferred code editor, we can add a simple function to access, for example, the application version, which is a static property and not associated with any game object or component within your scene hierarchy. As this value is a string, we'll create a public string function, getApplication version, which will simply return application.version. And that is basically everything you need to do for accessing static fields. In case you want to export a more complex type, you have to convert the type to a string. This is to prevent invalid data, for example, when exporting arrays, as converting those to strings will result in a string containing the pointer to the array's location, but not the content of the array itself. For example, if we want to get the values within an array, we can create a function with an array that we will create right now. We can call string.join with a comma between the elements and a space and call that onMyArray. And to make things a little bit prettier, we can add brackets before and after the contents. And this function will print our array correctly. Back in Unity, we can go to the data gatherer, add 2 elements to the list, and drag our game object with the new component in both target object slots, and then select under data export component the getApplication version, enter the export column name, and do the same thing for the getArray value. So using the DataBindings with a minimal scripting effort, only in a few cases will allow us to access every piece of data within our application. Also note that if you're changing the game object, for example, adding a new component to it, you will need to reassign the target object value. If we now want to test the values, we can use the manual export to print the values down here, but also the header. And you can see we will print the time as we have include timestamp enabled, and then our 3 data bindings, which is test, the name of the directional light game object, then the application version, which is 100, and then our array values, which we set to 0, 1, 2, 3, 4, 5. If we go back to the code and enter myArray.toString, we will see that the value of the array will be incorrect. You can see we have some system.int32 array, which is not the value we want. As mentioned in the beginning, the local export path will be calculated depending on your application and your VR headset. To find out the full export path, use print full export path to print the local export path to your console. If you want to manually export values during the runtime of your application within the editor, you can do that. If we uncheck periodic export and then start the application, you will see that a new button appeared, which allows us to export values manually. We click that once and close the application, and back at the location where we stored our data, you can see that now the values updated, where we have the timestamp, the directional light, and then our version, and as we didn't change that back, our system.int32 array. To wrap things up, let's have a look at the third option for exporting values or triggering exports, which is using other game objects. If we want to export the answers of a quiz, when they're a given, we can connect the unanswered given element of a quiz and drag the data gatherer into the object slot and select data gatherer and export new CSV line. And that is already it. And you can also call the same function using code. That'll wrap up this tutorial, so enjoy working with ExPresS XR.